Hello, everybody. Today we are going to go over some of the features we've implemented for OpenRegistry under the Filecoin DevGrants milestone number 2. OpenRegistry is a decentralized container registry, fully compliant with the distribution Spec, which means if you are already using something like Docker Hub or GitHub Container Registry or any of the ones offered by the popular cloud platforms, you can start using OpenRegistry without any hiccups. It works exactly how the regular container registries work, but the behind-the-scenes technology is fully decentralized by powered by technologies like IPFS, file-based storage, and Akash network for compute. Let's go over the feature list, and I'll go and explain all the features one by one. Starting with P2P container image distribution. This is a very big feature for OpenRegistry, which means now OpenRegistry can be run in a private network of sorts, or even in open network, depending on how you choose to deploy OpenRegistry for yourself. But what it enables is that you can essentially have a global shared namespace of container images, and then without having to rely on a single user or an org, you can share container images P2P. Let's get started with it by running OpenRegistry first, and then see how this feature works. Let's start by first creating a basic configuration. Let me show you what it looks like. There's a lot of stuff in this, but we don't need to go over all of the details. A lot of it is quite basic, like what address do we want to run OpenRegistry on, what port, some TLS and all that stuff. Not interesting. But the important one is this DFS and IPFS. DFS in our terminology is decentralized file system of sorts. But then within it, if you define IPFS and type P2P, then you can like define the address of your IPFS node on which the data will be stored, and that's pretty much it. Then let me just go and reset the whole of my local environment. And also, actually, remember, we also need to run an IPFS node so that OpenRegistry can connect to it and use it to upload all of its layers and contents over. We have OpenRegistry running now. So now that we're set up, let's log into OpenRegistry. If you have any existing container image, like I have BusyBox here, all you need to do is prefix the image with the host of OpenRegistry. Right now, OpenRegistry is running on this endpoint, and then we have a built-in global shared namespace of IPFS, so anybody can push and pull to this namespace. Is essentially how it works, like P2P. So what you do is you essentially just tag a container image with this prefix, and then you can just essentially just push it. So Docker push, there you go, done. Similarly, you could also do Docker pull of the same container image. If you already have the local one, which is up to date on the remote IPFS node, it'll just essentially skip the download step, is how these container engines work. Then, of course, you can push more than just BusyBox. You can essentially just push whatever you want, any container image, and all of them, they'll be listed under the public domain section on OpenRegistry website. But behind the scenes, it's essentially using IPFS now to upload your container images. You get these content addressable hashes back that you can use to pull these container images from any network. If your IPFS node is connected out on the internet, you could even just resolve these hashes out of different nodes instead of just yours. But the main idea behind The P2P distribution is so that you can create your own network, and then within your network you could allow who could access these container images. Moving on to the next one is private and encrypted container images. This is again very interesting feature, and the way it works is, if on OpenRegistry, if you try to push a container image, but then for that namespace we don't have a repository, it'll by default create one for you and set the visibility to private, so that you don't end up accidentally exposing your container images. But then you can also toggle the visibility from the settings page to public or private again. So let's see how this works. Let's log in into one of the accounts that I have here and go over how this works. So as you can see, I have one BusyBox container image. What I can do is it's set to public, which is indicated by this open log icon, and it's also written here as public. The container image visibility right now is public. You can click this toggle button and this will become private, and the lock becomes locked, indicating that it is now restricted in terms of who can pull and push to this container repository. You can view all the tags. So if you had like more than one tags, they'll all be listed here. Make your container images public and private. Other than that, we also have this new create repository option. You can select what kind of repository you want to create. Say I just want to do test repository, say description, something random, and create it. And there you go. We have a repository with public access. You can toggle it again, it becomes private. And this is what this feature is about. Next is OCI distribution spec extensions. This is not really a user-facing feature. This is something behind the scenes to enhance the overall functionality of the distribution specification. Like, the specification tries to keep the feature list as minimal and as generic as possible so that everybody can make use of it. Under the spec, for extensions, we've added some new APIs. Maybe I can just walk you guys through that. Extensions, probably somewhere around here. There you go. We've added a bunch of additional APIs on our registry, which essentially just help you explore the contents within the registry much better. You can list your favorite repositories, remove or add new repositories to your favorite list. You can also get your public or the whole catalog, which means if a single user has multiple repositories and split across public and private visibility modes, you can, by default, we only list the public ones. So if you were to like go to the explore page and see all of these repositories are public, and if you would want to see the full catalog, we also have get user catalog instead of just the basic public catalog, and you can like essentially see the whole user catalog, which will list your public and private container images. This is about the extension. There are more APIs, but this is not as fun to look at. Next is container image analytics, and this is not what it sounds like. Analytics is not always bad. We don't collect any serious amount of data from the users, but the analytics are only here so that the users of OpenRegistry can make better informed decisions about which container image to use and which to not. I mean, in the end, the decision is up to them. But the analytics are, you can now star a container repository, and you can also see the poll counter for these container images like this. You have like this Alpine image was downloaded 3 times. This is a preview environment. So this is not live out to the public. This is on preview.openregistry.dev. So this is one of our test environments. But how it helps our users is if a repository's star count is very high, that essentially gives you an indication of that people are using this container image a lot more, and then also are loving the functionality provided by it. So star count is sort of like an indication of a highly reputable container repository. Then the pull counter tells you how popular or how often a container image is being downloaded. It's also one of the trust factors for a container repository we have. The next feature on this list is container image vulnerability scanning. This is a very, very interesting feature. The way it works is if you have one of your container repositories, you can go and click this generate vulnerability report button. Since all of the OpenRegistry features are public and free right now, we only have very basic functionality for vulnerability report. In future, we will, of course, add automated triggering of vulnerability report generation when you push your container images, and also run it over a period of time. But essentially what you can do is you can go to the settings of your repository and click generate vulnerability report. And if our database finds any vulnerabilities for this particular container image, report back any vulnerabilities if there are. If there's nothing, then we just show this good, happy, green message. Let's see for something that might have a vulnerability, probably something like Redis. I think I did. Yeah, there you go. So let's try to fetch the vulnerability report for this one. And it says, well, that's a lot of vulnerabilities, but these can essentially be fixed if you were to upgrade to this version. It'll show you the actual CVE for the vulnerability that's listed here. Then we have gRPC APIs and more. One of the main reasons for switching to gRPC was performance, since the encoding and decoding of large amounts of data with protobuffers is a lot easier. It's very efficient on the transport. So a lot of these APIs behind the scenes, they use gRPC APIs. We also publish our proto files on buff.build. So anybody can go on and generate their clients. If they want to have like a custom client with some special functionality, they could totally do that. And that's about the gRPC APIs. The final feature that we did not implement actually is called platform agnostic security tokens, which is a very safe and sound alternative to JWTs, JWTs, if you want to say that. Essentially, the way JWTs work, they essentially just encode the data within a token. But anybody could just like decode the token and see, like if someone were to get hold of a JWTs, they could get the data encoded within them. It's not encrypted or secure in any sense. And platform agnostic security tokens, they sort of remediate that. But the amount of effort that we would have to go to and implement, the amount of effort we'd have to implement these new format of tokens was a lot higher, and the benefits are definitely there, but then we decided to not go with it since JWTs work pretty well for us right now. We only use them in cookies and for the Docker clients. So we just chose to not implement this feature. So these are the features that we've implemented. If you'd like to go and test it out, go to app.openregistry.dev and essentially just sign up, use, and maybe if you find any bugs, just report them back. And please share your feedback. We'd love to hear more back from you. We do have a GitHub on github.com/containerish/OpenRegistry. All of our projects are essentially open source. OpenRegistry, which is the backend and the registry and some additional APIs, is totally open source. Then we have OpenRegistry Web, which again is the web interface for OpenRegistry, is open source. Another thing actually I forgot to mention is the sign up methods. We have sign in with security key, which is using WebAuthn and passkeys as the underlying technology. We also have sign up with sign in and sign up with GitHub. And then we have the regular email password, the one that we just used in the demo. If you want to use WebAuthn, all you need to do is essentially just choose a username of your liking. Maybe I'll just go with GoUpload and use an email address. There's no need to use any password. There you go. The sign up is done. Now all you need to do is just use your username and click sign in. And voila, no passwords. And no, you don't even actually have to use password managers like the one I'm using. You could just use your hardware key. That's pretty much about it. Please do leave a comment and a likes and do let us know how you like it. Thank you.